Well, welcome. My name is Mr. Murphy, and again, I am going to be with you, teaching you this lesson 6-4, day 2, where we're going to be focusing on the inverses of exponential and logarithmic functions. Now, we've looked at inverses in the past of other functions, so we're going to apply the same skills, the same process to, like I said, exponential and logarithm functions. But first, I want you to try this warm-up on your own. So first step is I want you to look at this function, f of x equals the opposite of log of the quantity x plus 3 plus 1. And I want you to figure out all the different types of translations or transformations that are taking place when you would compare that to the parent function of just log of x. So try to do that without graphing it. I'll give you a hint. There's 3 different changes that are going to happen here. And then I want you to, don't worry about the x-intercept, so don't worry about that piece of it. But I want you to figure out what would be the new asymptote for this graph as compared to the parent function. So I want you to pause the video and I want you to find those pieces and hit play when you're ready to check to see if you've done it correctly. All right, hopefully you actually tried that, and let's see how you did. So first off, I got some highlighted pieces here to make these connections easier for you. Let's start with that negative. That negative, remember, is going to take the graph and flip it. So if you use the word flip or reflection, in some way talking about how it's either flipped over the x-axis or reflected over the x-axis. That's one thing that's taking place. And again, you could list these in any order. The second thing that's taking place is that plus 3. Now remember, that means that it's going to move to the left 3 units, not to the right 3. It's going to move to the left 3 units. And that plus 1 means the graph is going to go up 1 unit. So what does that mean for the asymptote? Oh, and by the way, again, we don't care about the x-intercept there, so don't worry about that because it's not negative 2, 0. But the asymptote would be at x equals negative 3 because the graph is moved to the left 3 units. So that means everything moves to the left 3 units. So the vertical asymptote that would have been at x equals 0 would now be at x equals negative 3. So hopefully you got those different pieces there in that warm-up. But now let's look at how to find the inverse of exponential and logarithmic functions. So the first step, remember, if we have it written in function notation, our first step is we're going to just write it in y equals form. Okay, so instead of function format, we're going to write it as equation as y equals. Then the next step, is we're going to switch the x and y values. So just the x and the y. So the y is going to change to be an x, the x is going to change to a y. That's your second step. So that's no different than finding the inverse of any other function. Now remember, the next step after switching the x and y would be to solve for y. Well, this is a little trickier because we have it in exponential form. And there's nothing we can do to that exponent. When we have a variable that's an exponent, there's nothing we can do except to change it to logarithm form. Okay, so don't do anything weird by dividing by y or anything like that. Okay, or taking like a y root. I've seen all sorts of weird answers in my years of teaching. The only way to address this, the only way to take care of this is to change it from exponential and get it into logarithm form. So let's review how to do that. So when we write something in logarithm form, your base for that logarithm is going to be the base when we're dealing with exponential form. So the base in exponential form is just a 10. So we're going to have a log with the base 10. And you can put that in there if you want. But remember, a log of base 10 is what we call our common logarithm. So you don't have to put the 10 in there. And then what we take, so then our exponent, when we have something in exponential form, is what a logarithm would be equal to. So now you can have log of x equals y plus 1 or y plus 1 equals log of x. It doesn't matter what order you put it in, as long as you'd have the y plus 1 being what the logarithm equals. And the value of what we're going to take the logarithm of is the value that we had originally. So originally we said 10 to the y plus 1 had a value of x. So if we're going to put this in logarithm form, we would say the log base 10 or the log of our value, which is x, equals y plus 1. Or the way that they did it here is they switched that around. So that's your next step. Get it in logarithm form. Then once we get it in logarithm form, remember the goal here is to get the y by itself. Sometimes it's really important to keep in mind what our goal is. So our goal is to get the y by itself. So to get the y by itself, we just have to subtract 1. Okay, so we're just solving for y. So we get y equals log of x minus 1. Now we have it as an equation, so the last step is we're just going to put it back into function form, but we're going to describe it as the inverse. So originally we had f of x equals, we're going to describe this as the inverse of f of x equals the log of x minus 1. All right, If you need to go back and pause the video and write that down or go back and hear that again, I totally understand. So if you need to do that before moving on, please do that. But otherwise, let's go on to the next step, or the next one. So here we have function g is log base 7 of the quantity x plus 5. So the first step is always the same if it's written as a function. The first step is to get it as an equation. So we're going to write it as y equals instead of g of x equals. That's simple. Second step is also simple. Interchange or switch up the x and y. So now we have x equals log base 7 of y plus 5. So far to this point, it's pretty simple. Okay, this is where it gets tricky. This one's in logarithm form. We need to put it into exponential form. So remember, in exponential form, we have a base raised to an exponent equaling a value. What's the base in this problem? Hopefully you're thinking and looking that the base is the base for the logarithm. The base is 7. Remember, all logarithms are equal to what the exponent is. So what's the exponent in this one? The exponent would be x. And the value would be y plus 5. So the book did it like this. They said y plus 5 equals 7 to the x power. To be honest with you, I oftentimes like to start with the hardest part first, which is the logarithm piece, and just recognizing what the base is and getting through that first, because that's really an easy place to start, starting with your base. So I would have, if it was me writing this out, I'd have 7 to the x power equals y plus 5. But that doesn't matter. It doesn't matter what order you put it in. So now we have it in exponential form. What's our goal? What are we trying to do here? What's our ultimate goal in trying to find in this whole process that we're doing right now? And that's to find the inverse. So we're trying to get the y by itself. So I just have to subtract 5 on both sides. So that's simple. So we get y equals 7 to the x power minus 5. So we're done. Almost. We just have to put this back into function notation. So instead of saying g of x, we're going to identify it as the inverse of g of x equals 7 to the x minus 5. And that would be your answer. All right. So how'd you do on that? Do you understand that? Maybe you need to go back and pause the video, reflect on what we just did, reflect on that process. But otherwise, if you feel like you're ready to move on, I want you to try these two on your own. If you're not ready yet, just take a minute, look back over those previous notes. But otherwise, if you're feeling pretty confident and you feel like you know the process, I want you to try to do as much of these two as you can. So pause the video and hit play when you're ready to check to see how you did on these two examples. All right. Again, I really hope that you did pause the video, and I really hope that you're trying this, because that's really the only way to learn is by trying it on your own. Even if you don't know the entire process, seeing how far you can get before needing to unpause and hear how to do this. All right, so hopefully you did the first part pretty easily as far as getting it at the y equals in the y equals form. The second step, switch the x and y around. So now I have x equals 3 to the y plus 2. Now the third step, this is where it gets tricky. It's currently in exponential form. We need to get it in logarithm form. So what's the base for your logarithm going to be? It's the same as the base of our exponent, which is 3. So we're going to have, so this is the way I like to do it. I like to say log of base 3, all right? Now what's the, so the log base 3 of the value is what it was equal to originally. So the value would be x. And it's equal to the exponent. All logarithms are equal to the exponent. The exponent originally was y plus 2, so it's going to equal y plus 2. So that's your third step, getting in the logarithm form. Remember, our goal is to get the y by itself. Now what I'm going to do in this next step is, technically, we might want the equation to be in the form of y equals. So in the next step, I'm going to do two things at once. So I'm going to want to get the y by itself, so I'm going to subtract 2 from both sides. But in doing that, I'm also going to write it as y equals, you'll see. So I'd write it as y equals log base 3 of x minus 2. And if you want to put that x in parentheses just to make it so you remember that that minus 2 is happening after we take the log of x, that might be good. All right, so then the last step is just put it back into inverse notation. So, or as a function notation, so we'd say it's the inverse of f of x. If you want to put that negative 1x or negative 1 power after the f or after the x, like the way the books does it, to be honest, it doesn't matter. I've always seen it as the inverse being f to the negative first power followed by the x, but both ways work. As long as you're identifying it as an inverse with that negative 1 exponent. And so the inverse would be the log base 3 of x, then minus 2. All right, how'd you do the next one? Okay, did you get through at least the first 2 steps? You really should have. You should have gotten at least through the first 2 steps. If you want to pause this video now and go back and try that, you can. But let's see how you did. So the first step, simply write it as y equals. Second step, switch those x and y's. Third step, this is where it gets trickier. So we're going to get it in exponential form. So right now, the base for that logarithm is 7. When we get it in exponential form, our base is going to be 7. Our exponent, remember, is what the logarithm is equal to. All logarithms are equal to the exponent. So the exponent is x. So we'd have 7 to the x power equals the value. And the value is what we'd be taking the logarithm of, the y minus 2. So we'd have 7 to the x power equals y minus 2. So the last thing, so that third step really to me, to be honest, is always the trickiest step. Because now all we got to do is get the y by itself. So I'm going to add 2 to both sides and then put it in the right format. So we'd say y equals 7 to the x plus 2 and then put it in function notation. So we're going to say it's the inverse of g of x equals 7 to the x plus 2. How did you do? Did you get those 2? All right, I hope you did. Now this last one is a little bit trickier. So I'm going to encourage you, if you want to pause it to see if you like mastered those, maybe just pause this one and see how much of this one you can do, because this one's a little bit trickier. I'll give you a hint. Before we change it from logarithm form to exponential form, I'll give you a hint. You want to get the logarithm by itself. So you want to get rid of the 12 and the 25. So after doing the first 2 steps, the first 2 easy steps, before we change it from logarithm form to exponential form, you need to get the log by itself. So if you want to try it, I would encourage you to do that. But otherwise, if you're not feeling comfortable, this is a trickier one. So let's go through it now and see how you do it. So again, the first 2 steps are simple. We just change the f of x to be y equals, and then we switch the x and y values around. And I just realized here that that should be a y there. Okay, so the next step is we are going to change it to exponential form. But like I said, we can't do that until we get the log by itself. So the first thing I'm going to do is I'm going to subtract 25 from both sides. Because just think, if I had the equation 12x plus 25 and I wanted to, or 12y plus 25 and I wanted to solve for y, I would have to subtract 25 and divide by 12 in that order. So we're going to do the same thing. I'm going to subtract 25 and then divide by 12. So when I do that, I'd get x minus 25, that quantity, all divided by 12, equals, and again, I made the same mistake. See, no one's perfect. And so we would have log base 10 of y, the quantity y plus 1. All right, so now we're at the point where we can change it to exponential form. And this is where it's going to get really tricky. So to get this in exponential form, again, we got to look to see what's our base. And I put the 10 in there because I want you to remember that this is a common logarithm, so your base is going to be 10. Our exponent is what it's going to be equal to. So we have that huge chunk that's going to be our exponent. That's all right. It's going to look weird, but there's no law saying we can't have something funky like x minus 25 divided by 12 as an exponent. You could have that as an exponent. So let's go ahead and write it that way. So we'd have 10, that giant chunk as an exponent, equals the value, which, man, Mr. Murphy, why do you keep messing up? I didn't even catch that. So equals y plus 1. So now we're going to do this last step, which would be to get the y by itself. Finally, I get it right. And so we would have y equals 10 to that big chunk, x minus 25 divided by 12 is your exponent, minus 1. And then we just put it back into function notation. So we would say it's the inverse of f. So we'd say it's f inverse of x equals 10 to that chunk, all minus 1. All right, that one was a tricky one. You don't have to worry about always doing ones that difficult, but it's good to be exposed to them and challenge ourselves. All right. This summarizes everything we've done in this lesson for lesson 6.4. So if you want to pause the video, make sure that you have all this in your notes, but you should have it in your notes already. But these would be the key pieces that you want to make sure that you understand and that you're walking away from this lesson with. Otherwise, good luck now as you work on your lesson 6.4, day 2 assignment.